All right, I am here to get back to work on my PE COFF generator project. And as always, reminder here at the beginning that if you like the channel or you like the projects I'm working on, or if you're interested in any of these perks, mrforth.com/membership is where you can sign up to support and keep these projects going. Now, I am going to get into this. I got a plan for today of what we need to work on. I thought of some stuff that isn't necessarily ready to go and some new stuff we need to generate. So that'll be good to get to. But before I get to that, I got a question right at the beginning of the stream that I'd like to answer that's not entirely on this topic, but it's a topic that I like to talk about. So let's see. Let's go and make a completely separate region for this. And the question is, what advice on programming without object-oriented programming do you have? How do you compose structs in a way that does not mimic OOP in C-like style? So just to turn that question into, just to put a little more detail on that question, what's being asked is, like, first of all, when you learn to program OOP, you learn to do this, right? Maybe something more like, this is sort of C++ style, right? Then you got like, and then importantly, you also have things like a constructor, and possibly a deconstructor or a destructor, depending on which language you're in, right? You get stuff like this. And when someone tells you to switch to C, the here we have OOP. When someone tells you to switch to C, there's this direct mapping of all of that into something that just looks like this. You just go, okay, well, I'm gonna have a struct, my struct, type var1, type var2, and then you're gonna have some functions that are like, okay, well, we're gonna need a thing that goes type my struct do something, and that's going to take a my struct and we'll just, my s for short there. And we might also need something that's like, okay, well, we're going to need some kind of way to create one of these things. So we create like a my struct new, and that takes the same thing as the constructor. And we might need a thing like void my struct release or whatever, right? And so if you just do this, now you've switched to C, right? Except the question rightly points out it doesn't feel very significant. Like you've used the exact same patterns and concepts and you put them through a rote transformation. What's the big whoop of switching to C if you're mimicking the same patterns you already have? So if And that's a good point. Someone in chat points out there is more to OOP, like inheritance and virtual functions. I can go into detail on those too, if you want. But I'm just going to attack the core of the question: how do you program without OOP? Right? If you learned this and now someone says switch to C and you find yourself doing this and you're like, hey, I feel like I'm still kind of doing OOP. I'm just doing it in C. The thing to attack is that you're still thinking about this in terms of, one, in terms of each of these structs having lifetimes that you manage like this. And so one very easy way to get out of this is to no longer allow yourself to default assume you're going to make a new and release for every type. Okay? If this doesn't exist anymore, if these were to be removed, what could you replace them with? And the answer is lots and lots of different things. If you start thinking about how you're going to lay out the memory for multiple structs at once, or how you're going to pack them in with other types of structs, how you're going to arrange them, you are no longer thinking in terms of OOP. You're now thinking in terms of what the computer can do. So the big lie in OOP, the thing that it does to make you feel comfortable but that isn't true, is it says that there are these things called objects, and the objects do things, right? The objects have verb behaviors on them, but that's not true. The only thing that does something is your CPU, right? The only thing that has verbs is your CPU, and the only thing that has nouns is your memory, right? That's it. And C lines up with this better. So you want to stop thinking that the doer of a thing is an object and start thinking that the doer of a thing is a CPU, right? Objects do not do anything. Only the CPU does something. And if you start thinking about what is my CPU doing and how do I make it do it, you will get, the more you think that way, the closer you will get to thinking without objects in your thinking process. Okay, so the way I tend to do that, the way I structure programs in my head is instead of thinking of objects, I think about my arrows. I think about what are my inputs and what are my outputs. And I decompose that in a lot of different ways. Sometimes I will go, okay, well, specifically my input is going to be key presses. And so I might have a list of those, right? And so I'll get specific. Like my input is a list of key presses, and my output is going to be a list of commands that got activated. And then I go, wait, well, that's not quite true. Sometimes a key press actually modifies a text field. So what's got to happen is at any given time, this mapping here, what this maps to is some kind of behavior here. I don't want to necessarily get stuck thinking about it as a list of commands forever. That's too rigid. And so I start thinking, what is the type that I'm really mapping here? What am I doing? And it turns out that I need something like, okay, I've got, let me see if I can erase this. I've got a list of input key presses, but I also have a keyboard focus. I have a keyboard focus concept in my system, and the keyboard focus is going to work together with the key press to give me some kind of state changer. So I have like a state of my program, and I need an arrow that goes from the current state to a new state, right? And so this starts to get rather rich and complicated. Like, okay, the mapping here isn't always a command. There might be other structures, but some way or another I'm modifying the state of my program. And I'm thinking in terms of, okay, input key presses and an input initial keyboard focus need to work together to determine, and you know what, now that I think about it, I don't just want one state change. I might want to be able to decompose my state changes into multiple state changes and make lists of them, right? And now it might not be the case that I actually want to return a list of them. I might want to apply each state change as they're discovered, and then you have discovered immediate mode GUI as an example, right? So point is, you can start to analyze and think about all of your programs in terms of what is coming in and going out at different parts of my program? What are my arrows and what are the ins and outs? And the more you think about it in terms of that, the less you have any incentive to think about objects, because these arrows they do not belong to any particular type of data. They are just the program you are creating. The CPU will be responsible for making the arrows come to life, and you are responsible for figuring out what the relationships are going to be between the data that comes in and goes out, the types of structures that you're building here. So this is how I do it. This is the trick. You don't think in terms of systems of objects. You think in terms of these relationships. It doesn't have to be pure functional. This isn't to say that it's like category theoretically sound or anything. You just think in terms of inputs and outputs. You think in terms of what are the arrows I am trying to build that map information to information. So I'm gonna check the temperature on the audience. How does this feel? Does anyone have any questions about that? And did you want me to go into the virtual inheritance method override stuff? Because that is another topic in OOP, and I can explain how I also don't need that because it doesn't do anything very interesting. But I'm curious if anyone actually wants to hear about it. Yeah, get used to the idea that like interesting functions take in lists of things. Interesting functions take output lists of things. You can't always be working on one object. And data structures. Think in terms of data structures. Very simple data structures, like a key press can just be a key value in an up or a down state. It's like a fixed struct. But a list is a slightly more interesting data structure, right? And data structure doesn't have to be like CS style, your lists and your arrays and your hash tables and your binary trees. Like, data structure doesn't mean those generic standard C++ template library concept. Data structure means literally any type, any file format, anything, any stream of data. Anything that is a way to know what the data means. You know, PNG is a data structure. ASCII is a data structure. Integer is a data structure. So on. Think in terms of your data structures. Each struct is a data structure. Combinations of structs are data structures. Your memory allocation systems are data structures. Everything. Okay. So, I'm going to get to today's main task, the programming task of the day. So, last time, I got the DLL loading working. We got exports working. We didn't do any base relocations. And I think that the DLL import is going to start failing if it can't actually import the DLL into the location. So this right here is success. When we get x equals 49 and we return a 49, then that means we loaded in the DLL. We were able to square a number with it. That's all good. Now let's take a look here. I think if I mark this as a 4, this is just an arbitrary number that we put into our executables that we generate that tells it what address to use as the base for that particular binary when we load it into the process. So now if I generate this, I suspect it'll fail. It didn't fail. Interesting. How can I figure out? Let's go into main. I need test load gen. And we're going to do a little modification here. We're going to say square the address of square equals boom, and then I'm going to just print out the address of the square function. All right, got another question. I'll get right back to that. But let's see, test load gen, build fly. I will answer your question. Don't worry. Highlight, line it, cursor. Test load gen build. All right, so to answer the question, I feel like having a matrix inverse isn't really OOP though, right? It's just syntactic sugar that basically gets compiled down to C, matrix inverse, matrix. To be honest, my definition of OOP is very fuzzy, and I'm not totally sure what is and isn't OOP. Sorry if I'm a bit late. Okay, so this is a good point. So you're saying, say I've got, is this OOP? Classic question. Nobody can answer it because nobody knows. It's got whatever. It's got a public section. It's got an inverse. Function. It's got some other stuff. Who knows? We don't know. Close. And the point is, isn't this just, you know, so inverse is kind of equivalent to if we just had like our struct matrix and then, you know, the C void inverse matrix. And yes, these are just equivalent. And we could also, if we were going to just do abstract, forget programming language, not C++, not C, not OOP, not procedural, not functional, not anything. Forget all of that, just diagramming it. We could just say, well, matrix inverse is like this thing where you go from matrix to matrix. And that can be, you know, in the diagram, it doesn't necessarily look destructive anymore. It looks like it's an input and an output, but that could be destructive, right? And this is our inverse function, our inverse arrow. And whichever language we're choosing, whether we're speaking this language or a different one, if it's a programming language you can actually work with, there is some way to make this arrow exist in your program, right? So I don't really care if you like this particular language, this particular syntactic sugar, this syntax for making your arrow, then fine, go for it. It doesn't make that big of a difference. However, you're still going to want to make sure that you've got your head on straight in a certain sort of way, which is, even with this, say that you only need to invert one matrix once in a while. Great. But are you really cool with the fact that it's a destructive inverse? Wouldn't it be nicer if you had something like matrix inverse matrix, right? It's a little bit nicer whenever you don't have to use destructive functions, right? So there's one thing. The object-oriented thing kind of invites you to think of your functions as destructive by default because they take in an instance and modify it directly. So this is destructive by default. This one here is explicitly destructive. You can easily choose to make it destructive or not destructive with that language. And of course, you don't have to make this one destructive. You could return a matrix here. You know, you could. But like, I don't know. I think this is like small potatoes. The more interesting thing that's gonna happen is like, when the time comes to use your inverse matrix, how many times do you have to recalculate it? So where are you gonna put the inverse? Where are you gonna apply this arrow in your system? Where are you going to do the compute work. So if you like the syntactic sugar, fine. I prefer languages. The interface for constructing software that we make doesn't need to be so complicated, and to me this is like extra complication for tiny little nothings of an advantage. This works just as well, and it requires much less compiler tech. I don't see why that isn't preferable, but I know some people really like the syntactic sugar. So yeah, it's just style, except personally I prefer tiny compilers. So let's wrap this up here. Okay, so we've rebuilt our our test program, and there. Okay, so interesting. I think that the reason this is going to work is that there's nothing to relocate, right? Square works no matter where you place it. It does not have any need to be relocated. So what if we let's see. When I run my dumper on test.exe, base relocation table, base relocations. Okay, so this does generate base relocations. I'm curious if we can get an idea of like what the significance of base relocations are in this exe. So let's drop these for now. No, I didn't mean to make any changes. Don't save any changes. Let's see here. So we're looking for, what is the deal with this window always staying on top like that? It's kind of annoying. Can you not do that? That's lame. Okay. Does it always behave like that? No. Okay. So I want to look at test.exe. It's the one I just dumped. Yes, load up the PE hex pattern. Right, where's my file though? Failed to open provider. Unspecified error. What are you talking about? What are you talking about? Failed to open provider, unspecified error. Huh. What if I open file, test.exe? Same thing? That just isn't working. Alright, this is a little... Yes. Huh, it's not opening this one. Alright, let's try... Mini? No, we don't want one of the minis. Those are small. We don't want Euler. How about this? Does this work? Yes. No, it doesn't work. What's happening today, Imhex? Why did we fall off a cliff? You were doing really good by me for the last couple weeks. Yes. There it is. Thank you. Okay. Okay. So, base relocations. Now, VOFF 37000. So we got to figure out what section contains. We got to go to our section table. 37000 in hex. Pull up my calculator. 225280. Okay. Okay, and the size of this is only 60K, so that's not big enough. That could get us up to 2, right? Oh, that's only 8,000. That'll only get us up to 20. 208. We add in a 5 there, we'll get to 213, 214, probably not. 217. Add in the 80 bytes, and we get very little more than what we already had. 221184 plus 300 more. Yeah, that'll contain what we need. 225280. 225. Okay. So 225280 minus 221184 plus 201216 gives us a file offset. Whoops. Okay, that's not right. Okay, so again, 3700 now minus 221184 plus 201216 205. Okay, 32200 is our file position. 32. Okay, so that's garbage. That's just wrong. Two oh one 216. 312 is the beginning of that section. We're looking for 37000 in hex. Three six zero zero 36000 plus 31200. Yeah, that gives us 32200. That doesn't exist. What am I doing wrong? I'm not understanding what I'm doing wrong. Just to double check, am I looking at the right file here? I put in test.exe right here, and I dumped test.exe, yeah. Am I looking at the wrong data section still? It's possible, I guess. I'm looking for 3700, and our data starts at 36. Relock, okay. So relock is the section I actually want. Relock starts at 37, so my 37 would point right to it, and then goes to, okay. 37000 minus 37000, 0 obvious. 31400. Okay, so it's just 31400 is where we want to start. Which is right here. That makes sense. And when I look at base, wait, how big is the base relocation table? 1628. And how big is this? 1.6 kilobytes. Looks like it's the whole section to me. So now when I look at base relocations, remind me how we parse those. First we have a block. Page v off. Yeah. Block size. And then base relocation type. Offset base relocation type. Offset base relocation type. Offset base relocation type. Yeah. Okay. All right. And so this voff 21340 is encoded right here as the 135168 plus 832, which gives 21340, 21340. So there's our voff. 21340, now I have to map that into the voff space. 21340 looks like it would be inside of our data. 21340. Okay. So going to hex, 21340 minus 21000, so 340, plus the f off, 1fe00. So an f off of 20140, 20140, 20140. That's going to be up here. . this looks interesting. I bet, if I had to guess, I bet that these are export symbols. Where is our import address table? 21000. Right, so it starts right at 1FE. There's the import address table right there. And these are relocated with base relocations. So what I'm trying to figure out, in case this wasn't clear, let's take a step back and think about it. I'm trying to figure out a case where you need base relocations to make things work. And the way I thought exports get exported as a section plus a v plus an offset, which means they'll get resolved down to a voff. Hey, welcome. Someone has just joined us. You want me to get you caught up, I assume? So I am working on a generator for executable files. It's not a compiler or a linker. It's just generating valid files, hard code in the binary data that I need for it to work, to do stuff. And like right now, I have it generating a square function. So I've got like, here's the assembly, here's the raw bytes. It puts that into a DLL, and then I can load that in. I have a little test loader program that loads in my generated DLL and loads out the square function and calls it. So we are generating our own DLLs and pulling code out of them to execute directly. And we are trying to figure out right now how to make it so that the DLL doesn't work so that we can fix it. So basically, there are features we don't know how to generate yet. I am trying to come up with a use case for base relocations, which is a feature that sometimes DLLs need, but for some reason my DLL doesn't need it yet. It works without them. So I'm trying to figure out how to make my DLL a little more complicated so that it does need base relocations, and that way it'll start failing, and then when I generate the base relocations correctly, it should start working again. Now, I've got a test program here that has a relocation section that contains base relocations. And when I go here, I can see like, okay, the base relocations here match. And I've also got a dumper that I can run. And when I run it, I get my base relocations. Wait. project.forcoder run dump. Oh. This one. Base relocations, they live down here in the reloc section, 3700. Base relocations, when we print them out, we see this, 21340 is the VOFF. We go to our sections and we look for what section contains that 21000, so 21340 is here, 340 plus 1FE plus 340 gives us an FOFF of 20140. We go to 20140. And unfortunately, the hex editor doesn't actually know what this part is for. So I don't have any clue from this why we're relocating this part right here, or this part right here, or so on and so on. So I could keep looking through the relocations and see if there are any in later sections. So these are like every 8 bytes they're being done. A8, B, da, da, da. Here it jumps ahead, 2190. Let's try to look at what those might be about. 21900 is the VOFF. Now, looking at the sections again, that's still going to go into the RData section, so minus 21000 plus 1FE00 gives us a file offset of 20700. Once again, we're not getting any markup about what this means. We get one there. We get one there, and then it skips this chunk. So we get this one and this one get relocated. It skips this chunk, and this one gets relocated. Skips this. This gets relocated. And now it's skipping. Yeah, so these are all getting relocated. We don't know what they are. Like if these are VOFFs or VAdders, 1, 4, that kind of makes sense. So let me write down the hex for this thing right here. So let's go to one of these. We'll pick one that we'll stick with. Where's that FF? So we'll stick with this one. 20700 gives us this. Copy, paste. So that's actually the hex number. We've got to reverse it because a little endian this, which puts it at VAdder 14, like 14 up here in the big part, and then 000. So yeah, let me decompose this for you so you can see what I'm seeing. That's the default base address on Windows, and so this is the offset from the base. Here's a VAdder, here's the VBase, here's the VOFF, right? Does that make sense? And so the VOFF we can work with within the file. 30EA0. Let's go back to our sections. Now, let's see. VOFF 30EA0 must be in the data section. 30EA0. 30EA0. Okay. So all that's going to leave behind is EA0 because we're going to subtract off the VOFF, and then we're going to add in the file offset 2EA00. – 2F8A0. Let's go check that out. 2F8A0. It's unwind information. Okay. That kind of makes sense, actually. That's one I don't have in my system yet. So let me see if I can build... Question. So this is not architecture specific. It can run in any Win environment. So my generator so far is directly outputting x64. This right here is x86-64 bytecode, or like instruction code, machine code, right? Like this could not run on an ARM machine or anything that isn't x64. I guess it could run on a 32-bit machine or a 64-bit machine, but this is architecture specific, this little chunk right here. Now the main project is not to be architecture specific exactly. But I need some code to make it work. I'm trying to focus on like being able to export all the data sections that you need for relocations and exceptions and unwinding and debug. Like I want to be able to export all the stuff, but I have to have a working piece of code to actually test everything's working. So there's a little bit of architecture specific. But that won't be a very big deal as things go on. And at some point, I'll probably actually put in some built-in assembler helpers and stuff too, so you can generate code that way at some point. But the point is, I need to figure out something I can do, and maybe base relocations aren't it, because it looks like it's not relocating this. It says it's got a dynamic base. But when I change the base... Okay, it did move this. So that is fine, I guess. It's placing the DLL successfully at a relocated address already, because it's not placing it here, obviously. So it seems like I can just do whatever I want with this, and it kind of figures out how to make it work. That builds the generator. This runs the generator, right? No, does this run the generator? I need to relearn my key bindings. I'm a little confused. Run gen is F3. What is run gen? That runs generated exe. Run fly. What is that doing? Ah, it's not doing the regen right now. That's the problem. Okay. F1, F2, F5, F5, F5. Boom, scratch. Pretty sure it can just do whatever it wants. With that base address. Yeah, so I can move the base address around right here. And it doesn't matter because it's successfully relocating my square function. If I wanted it to need a base relocation, what I could do is include a global variable. So let's and access that global variable through a direct address. So let's see, how are we going to do that? We're going to go over here, Felix Is there an 8-byte mov literal? I think there is. I don't think there are very many 8-byte literal instructions, but I think mov is one of the ones that can do it. IMM64, there it is. Okay. So let's try to get mini asm to perform an 8-byte mov before things are over. So I want to know how to move into ECX, into RCX, IMM64. x64 Intel syntax 64-bit immediate. This is the wrong syntax. Maybe I have some examples over here in the Euler ASM file. I always forget the syntax for this is the thing. Just one immediate. Okay, let's just try. I just need a hex though. What's the syntax for the hex? There it is, right there. So let's try 1, 1, 2, 3, 4, 5, 6, 7, 8, H. Have it rebuild the mini ASM for me. And then we're going to look at the mini.exe again. We're going to look at the text section. Begins right here. And it looks like this. Seems short. Seems like it only has one return instruction when I thought it would have two. Right, this is the DLL, not the EXE. There we go. Now we go over to the text section. Here we go. All right, so we've got this right here is 1, 2, 3, 4, boom, 8 bytes. Goes with the mov RCX, mov EAX gets the 1 byte there, and then the ret. And this is B8, so rex W is this guy. Plus B8 is this guy. I know it looks like a B9. That 9 is probably because there's an extra bit set as a flag. That's B8 plus the W flag, for instance. Then the 8 bytes that make up this thing. 2 to the 32. Then one instruction that does the moving 1 into EAX, and one instruction that does the 1 byte does the ret. So this would allow me to move any 64-bit value I want into RCX. So first I move the input into there. Next I'm going to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is mov RCX 1, 1, 2, 3, 4, 5, 6, 7, 8 H. You don't think that the fact that this says B8 and then I got a B9 from the assembler is explained by the possibility that the rex prefix puts a flag right here? I mean, you could be right, but I don't see a B9 anywhere. And this is the right form. R64, immediate 64. Ah. B8 plus. That makes sense. Thank you. That makes sense. So now I've got the ability to put something into RCX. And then when I multiply EAX with itself like that, the next step is I want to load, I want an instruction like mov RCX keyword putter RCX, something like that. Is that going to work? Looks like it worked. Yeah, let's reload this again. Rerun the pattern. And then let's see. So our first ret is now here. So here are our bytes. Copy. Scratch. Okay. So there's the first big mov. Here's the last one. Here's the ret. So this right here must be a move into RCX from a memory 64-bit. Let's see. R64. M64. Rex with W plus 8B. That's what we've got. And then, yeah. Postman asks, what is the purpose of this project? So, it's a good question. Right now it is a research project, so that means I am doing all of this not to end up at a particular product that I have in mind, but to gather lots of information. What we are doing is we're getting better and better at understanding all the quirks and difficulties that come up when dealing with binary files of the PE-COFF format. I'm also going to do this for ELF at some point too, and over time, once we've gained more and more mastery of the subject, it will become easier and easier to do more interesting things. So hopefully there'll be a couple of side effects. One, I can turn a lot of what I've learned into synthesized information for other people to go faster at the same kinds of stuff. Two, once we get to the point where it is easy to pick apart and assemble our own executables, then we can start thinking about creative ways to use that capability to do other things. Certain things, I think there's a lot of options of what we could be doing there, things we could play with, but it's hard to be playful with it because it's so opaque and poorly documented. It's hard to get a handle on it. So I'm trying to do the work of getting a handle on it and get that information out there and maybe make a library for it or some example programs or something. And then hopefully me and other people who are interested in this kind of stuff can play with it faster. But I'd love to live in a world where we could write our own little programs that generate programs for us without sweating it. Like I don't want to have to wait for a new linker from a giant, toolchain team. I don't want to have to wait for a new compiler language. New compilers and new languages is like leaving all of the binary generation work coupled in with really big heavy duty toolchain stuff is not getting us anywhere anymore. So I'm trying to take a different approach. Right, so this one looks like we got the REX byte, and then we're moving that into there. So I should be able to load an 8-byte value into RCX from whatever pointer I want using this. All right, and then one more time, I want to get the add instruction as well. C3. Don't care about that one. There's our return instruction. There's the one. Okay. Felix, can you confirm? Add. Show me add. Right up here at the top. Looking for REXW plus 03 R64. That looks like the right thing. So once I've loaded something into there, I should be able to add it into EAX like this. Okay. So This is cool. What we need now is a data section where we can put in a global variable like that. And let's say we're going to be squaring the input and adding 1. Just 1, right? So we're going to be loading this right here. Now, right now I've got that encoded as 1000. Let's say our image base. Okay, it's this number, so we want to make it that. And then we also want to add in, where's the offset to the data section going to be? Well, text goes first. That goes at 4K. This is going to go at 8K. And 8K is going to be at that spot. Right. So there's our direct pointer into the data section. And so that builds it. This runs the generator, and this should crash. Very good. So if we want to, we could go through the debugger and see that crash ourselves. That might be nice. Let's load up a new... Does Remedy... Okay, well, it's fine. So square is no longer the name I want to use. Test load gen. Instead of square, we're just going to call this operate. Rebuild everybody. Rerun the generator. That should still lead us to a crash, but we get the operate function, right? Show me operate. Okay. So build fly, please rerun the build for test load gen. Thank you. Step in, operate, comes back, procedure load success. We step into operate. We do not have source code for operate. We just have disassembly, but that's okay. Let's look at our registers here. We move ECX into EAX. 7, the number we want to square. We square it. 49, written as a hex. Right. Then we move into RCX, this address here. So RCX is going to become that. Let's look at it as a hex. Very good. And then we're going to try to read from that pointer. So, show me the 64-bit integer that lives at RCX. And the answer is none, garbage. It doesn't exist. And that's because, even though I've encoded it correctly from the perspective of the DLL, it got loaded somewhere else, right? Notice our code has this funky address. It does not look like 180001 plus a little bit of offset. It's all this. So it's been relocated, but this did not get relocated. So now we should be all set up. We have an example where we can generate our DLL and then try to load it, and it fails because base relocations are missing. So now I should be able to try to generate base relocations, and if I do that correctly, it should work again. And if that does work again, then we'll know we did base relocations correctly, and we can call it success. So I'm about an hour and plus a little bit in. I think now would be a good time for me to take my 5 minute break. And when I get back, we will actually get to work on that second half, which is generating the base relocations. All right. So give me a 5 minutes, and we will move on to the really fun part. See ya shortly. All right. Let's see where we get started here. So base relocations. Our goal is to generate them. We need to start by understanding, fully comprehending the data structure of base relocations. So let's pull up the relevant documentation. Not COFF relocations, base relocations. So we have these block headers, which are 8 bytes. And then 4 bits gives us the type of base relocation, and 12 bits gives us the offset. 12 bits is enough so that these can be .4K aligned. Okay. We have base relocation types ready to go. So basically, let's zoom in here and get it going. I'm trying to diagram out this data structure. What are we looking at? Ultimately, we're looking at a list of offsets and types. The offsets are V-offs. Base relocation type and a V-off. Right. That's what it is. Now it gets encoded in a funny way for compression purposes. But let's take a look at our base relocation types. What have we got there? So we have something called absolute, which is no op. We've got something called high. Which does so this does add 16 at the relock putter, and the amount we're adding is bits 17 through 32 of the difference between, the difference being the difference between where we thought we would load this and where we actually did end up loading it. This is the same thing again, except we're looking at bits numbers 1 through 16 now. Of the diff. High-low. So high-low is add at a 32 bits the diff, right? I keep going and going. So these are this is a special case. Which goes like this: add 16 relock putter bits 17 through 32 of the difference, and relock putter 2. There's a second relock putter which gets the 1 through 16 of the difference. The next several are all architecture specific on architectures we're not using, and then there's the space dir 64. So I think we're just doing add 64, relock putter, diff 64, right? Okay, so I think this can be pretty easy. I'm gonna put on some low-key music. Cool. For now, I don't want to think about packing this. I can do that later. Okay. All right, so these first two functions here are just our construction helpers. This last one is the data baker. And so we're going to come back to that and do it later, because that's where the real work has to happen. But first, let's go and use the new API. Okay, so our base relocation is going to go at well, first of all, the type of base relocation should probably go first. Base relocation type dir64. So we're doing a 64-bit base relocation. And we want the label at text section plus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now you'll notice I made a mistake. I thought it was v-offs. It's actually gonna have to be labels because we don't know the v-off for where the base relocation goes until after layout. And so as usual, we have to use a label to point to the piece of information that gets modified later after layout is done, because we are specifying all of this before layout is done, right? And so our base relocation can't just be a v-off, it has to be a label. It doesn't become a v-off until it gets baked. And that's okay. So what we learned is okay, so base relocation new. And that's it. We just point at it. We don't have to tell it what it points at because it's already set up to point at the right thing. It's just that it needs to get shifted. Right? V-adder base relocations are simpler than pointer patching because it's still up to the original system to encode the correct v-offs or v-adders here, given that no relocation happened. Okay. Now what's left is to actually bake and to bake this we need to do a couple steps. So the first thing we need to do with this one is we need to sort these out. So we're gonna need some scratch memory. And we need scratch memory because we're gonna make an array of pointers that we can sort. And we're gonna iterate all the base relocation nodes that we made and stick them in like this. Okay, so we flatten out our linked list into an array of pointers. Okay, merge sort, or sort, merge, here we go. Sort requires, we gotta give it the base relocations. Tell it how many of them there are. Okay, so we need a new pair functions look like this. A reloc equals A, B, B. Uh-oh. Uh-oh, 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 uh-oh. Oh boy. Things just got complicated. We can't sort these. We can't sort them until we have their VOF versions, and we can't get their VOF versions until after layout. Damn. It's kind of hard to figure out how big this will be until after layout is done. But then it has to become a part of the layout. So the layout has to be done iteratively. We have to lay out some of the stuff, calculate more stuff on top of that, and add that to the layout without modifying what's already there, which is going to explain why the relocation section always ends up at the end. But damn. Okay. Okay. Alright, so this just got more complicated. Yeah, I mean, practically speaking, there's a way to do it. It just complicates the flow of information. There's no longer a clean divide of, like, you prep all the data, you run the bakes to generate some of the data sections, and then you lay out the data sections and apply pointer patching. Pointer patching isn't going to be strong enough of a post-layout tool. So this has to really be generated. The data section itself has to be generated after the rest of the layout, which just complicates the flow of things from what I've had so far. And it's going to require a little refactoring to make it work. We're going to have to learn how to do a layout and then add stuff to the end. That's okay. So let's back up here. Exports, yeah, something like this will probably, not exports, sorry, base relocation. Something like this will probably be correct, but let's just take it out for a minute. First, what we have to do what do you think? Do I need a little time to think this through? Before I go any further on this, let's figure out how to modify the layout with a new relocation section first. That's what's going to make me more comfortable. So say I get this far, I run layout. So let's see, our flags here are PE section flag contains initialized data. PE section flag mem discardable. PE section flag mem read. Oh man, this is weird. Okay. The whole architecture is like reforming in my head now as I think about this and what I might change. I've got ideas. Okay. Yeah, we need the base relocations to span farther than we thought. I have to give it the layout. So here's the section we're going to fill. Here's the layout that you need and the base relocations that you need. That gives you a data range. And we set the data directory. And then, having done all that, we do layout again. So that's kind of like the hacked version. And then what I really want to do build layout system with API for incremental layout. The one big risk is that the relocation section, when it gets added, could grows the section header table, which could, in theory, mess up the layouts. So it can't be the case that we're modifying the list of sections we have to think that through. It's going to get more complicated than this. This isn't right. Is that what we want to do? Have to think about options there. Okay. Okay, now let's try to build big base relocations, but this time it also takes a layout. Instead of flattening to an array of pointers, we need another version of this. That can just look like this. Have I got a V off from label yet? Yeah, I do. Using this layout and this label, give me a V off. Good. So I've resolved that to an array, and then I sort the array. If A is greater than B, if A is less than B, that sorts our array. And now what we do is we bake the base relocation data. And for that, we do a loop. Like this. We zero out the low 12 bits to get the block base. If the block base for this relocation does not equal the last block base, emit block header. Gen section data push array gen section one new block header, please. And the block header has a page voff of block base voff. And then the block size, we're going to have to save for later. So let me do this. If block equals 0 or block page voff does not equal block base block page voff, let's just make a match. Block page voff. Then we make a new block, save the new voff, we remember that block for later. Then we emit a base relocation. And for that, yeah, so for that, all we do is we're going gen sec u16. It's one of these things. Emit one of those. and you go reloc equals base relocks I dot type, bit shifted up by 12, ORed with base relocks I dot voff minus block, and oxfff, right? So we get 12 bits and 4 bits. OR them together. That should do the trick. Now, if we come around here and we get to this point, and if block did not equal 0, then two things have to happen. One, we need to do an alignment push. Filling it with 0 bytes to align to an alignment of 4. And we need to go back and write into that block the actual count. Block size. Now, block size, what is that measured in? The total number of bytes in the base relocation block, including the page RVA and block size fields, and the type offset fields that follow. Okay. So if that's true, then the size is... Well, let's just keep a running total, shall we? Block size starts off at 0. When we create a block size plus equals the size of the block we create. Every time we push one of these, block size plus equals the reloc that we push. Yeah, there's an even easier way. Let's not do this. The block size what we'll do is we'll get the block start position by going section data get size. So we get the current size of the section. And that's the start position of the block. And then when we're done, if we have a block, then the block size is equal to the final size of the data section minus the start position of the block. And that gets stored there. So this is just current position. Start new block. Close current block if one is open. Okay, so now our base relocations, they get a layout, they get a list. We resolve the list into voffs using the layout that we've got. We sort those, and then we bake. I wonder if we could do this with pointer patching, actually. I bet we could, now that I think about it more carefully. It seems like pointer patching could actually do it. So let's see if this works, and if it works, then I've got the right main idea in terms of how base relocations work. But then I want to try out a subtler, perhaps less complex way of baking them. See if it just works out clean or if it's kind of a mess. So there's that. We try to regenerate and we get a seg fault. So let's open up PEgen, run this until crash. Right, I didn't return the data range, did I? The initial pointer just points at the first block. There, the generator runs. That doesn't look relocated to me, weirdly enough. It's certainly not adding the global in either. Weird. Let me think. Load gen, still set up to load generated.dll. Let's step through test load gen here. Library loads, operate loads, we call it, we move into RCX, a pointer, and then we load the pointer. Well, I can tell you one thing that's definitely wrong. Is I forgot to set up the data section, right? Like right here, I am assuming a data section. There it is. But now it's not relocated. So when I give you base relocations, you stop relocating the file. But when I generate this without base relocations, it crashes. Okay, so in order to do this fully properly, let's now say, excuse me. You know what? I forgot to light our programming candle before the stream today. Let's fix that. Now it crashes. Okay, so kind of makes me feel like the base relocations aren't working quite right. Let's go in here and let's open up generated DLL. Yes, parse it. And looking at our relocations here, we kind of want to see how does this table look. If I jump to it, okay, page RVA 4096. Yeah, block size 0. There's a mistake. If we get to the end of the loop, finish, close final block. If block does not equal 0, then we're going to do this work again. Whatever. Kind of overdoing it, I think. Kind of overdoing it there. I could just get away with calling it twice. Make it simpler. This should be fast. I don't know. We'll just do it. We'll just do it. Robust. Don't overcomplicate. So 14000 doesn't work because relocations don't actually work. If I do this, then it just works. Oh, but it relocated it and it worked. Okay, so that definitely relocated it and worked. So the problem has got to be that this was encoded with a different base image. Or image base. There we go. There we go. That's base relocations working. So now if I have a DLL with spots in it where there are 64-bit pointers that assume they understand where the image is being loaded, but then I actually need to relocate the image, the base relocations let me fix that. Cool. But we made kind of a mess making that happen. So let's see, I'm at 2 hours today. I think that now is probably a good spot for me to wrap up for today. A lot has to happen to clean up after this little push. I need to, one, Yeah, I've done this part now. So generate base relocations is working. I need to do a new layout system that can maybe handle incremental better. I need to figure out, can I use my pointer patching system to make the 64-bit image v-adder pointers easier to fix up? Can I use my pointer patching system to make the base relocation data work without having to modify layout? These are some questions I need to answer, and if I can't do that, then I need to invest in an incremental layout system. So I think that this is stuff I'll need to do next. Possibly do some of this research before the next stream, and then maybe next stream we can work on something like imports, or imports probably. Valbus, yeah, it would be a lot more complex to do an OBJ file for this rather than hard coding the assembly. I can read OBJ files and dump them, but extracting assembly out of them isn't as easy as it might sound, because it doesn't, like, for something like this, it wouldn't have the correct pointer anyway, and I would still have to figure out the offset to the pointer and fix it up. So like hard coding this just gives me direct control, whereas the OBJ would be very indirect, and I'd have to do a lot more, I don't know, sort of hacking work to actually get what I want out of it. I can understand how it seems like that might be ideal, and there is kind of like, in the long run, what I would love is to be at a place where I could do something kind of like on-the-fly linking in my own code and be like, oh, let's grab in this object file and patch it into the program that I am piecing together here in my own custom way. That's definitely where we're headed, but that's like more advanced than hand coding this. That is not less advanced, but it's a good idea. It's the right idea. With that, I think I'm gonna wrap it up for today and maybe do some of this off stream, and for the next stream we can look forward to something like building the imports table or something. All right, so keep in mind that all of this, everything I'm working on here, plus my YouTube videos and blog posts and stuff like that, is all funded by people who like what I'm doing and think that, hey, I could afford $5 or $15 a month, or you can go for a yearly option. And if you like the perks, if you like the stuff I work on, do consider that, because I am counting on as many people who can as possible to make that choice so that I can keep doing these projects. And with that, I will wrap it up for today, and I'll see you all around the internet. Bye.